Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming to you from the Mozaic Works studios. And today, unfortunately, it's a sad day. I have just learned from a tweet from Grady Butch that Fred Brooks has died. And so this is a very quick reaction to this news. I have not done a lot of research for this. I will speak from what I remember about Fred Brooks and how he has influenced my career until now and the things that I've learned from him. Perhaps some of you don't know who Fred Brooks is. Fred Brooks is one of the legends of software development. He is an engineer who was also project manager in one of the, let's say, first big projects. And he learned a lot of things about how to run projects. And the problem with Fred Brooks is that everything that he wrote, the things that he wrote are very insightful, but we still don't follow them. I feel there are a few books and topics like this where this industry makes the same mistakes again and again and again because we just don't read those books. We just don't apply the learnings that we should have already known because they are part of our history. And Fred Brooks is one of the people who has generated some of these learnings. Another one is the refactoring book by Martin Fowler. Everybody talks about refactoring, but very few people actually go on and read the book. And even fewer people actually go on and practice refactoring as described in the book at the end of in the exercises at the end of each chapter. So, needless to say, there's been a whole bunch of reactions to this, people remembering him and, talking about his timeless insights and how smart he was, and talking about the Mythical Man Month, which is, we'll go a bit into his work. And so on. I mean, these are just, I am touched, honestly, by this reaction because I tend to be a bit cynical about this industry and about the fact that we don't really learn. We don't really learn as fast as we should. About this, right? So let's talk a bit about Fred Brooks. Born in 1931, so he was 90 years old, 91. Never do math directly, but 69 plus 22. Yeah, he was about 90. And best known for managing the development of IBM System 360 family of computers and the OS 360 software support package. And these were massive endeavors at the time. So just to put this in context, remember that we didn't always have the processor that we have today and operating systems that we have today. And so writing a new operating system for mainframe computer, which huge market, right? This was a very complex endeavor. Even today, writing an operating system is very complex. But we are lucky that we have a set of operating systems that we can use, right? They have become, you can just pick them and use them, and it's not that hard anymore to do that. But back then, when people were, creating a new family of computers, there was also new operating system or new things that they needed to write. But I think the best thing about all these adventures, not only the system and the project was so complex, but then here I like this thing. He said, then later writing candidly about the process in his seminal book, The Mythical Man Month. And this is indeed, I think, the best thing that you can get out of Fred Brooks and it's something that's very rare today. Books written today about projects, and actually very few books in software development are written candidly about projects. He was not afraid about talking about the mistakes he made and about the things that didn't go well in the projects, and completely accepting responsibility for it, but at the same time knowing that, okay, I have done this wrong and these were the mistakes that I made, but what were the causes? And he went into a deep analysis of the causes for the delays in this project. And today you rarely see that. You see people writing about projects that went well, and you hear about successes and you hear about technologies that are shiny and new and so on, but rarely talking about the things that are really important, which is, what are the limitations? How did this not work? Right? Why? What have we learned from this project? And so I'm not going to go through his whole career, which is impressive. It's an impressive career. He is one of the first who got, I don't remember which one of the prizes, but he got a number of prizes. Yeah, look at this list of awards and honors. I mean, this is very impressive. But let's go to the actual things that he discovered. So a few years after leaving IBM, he wrote The Mythical Man Month. And The Mythical Man Month is a book that should be mandatory reading for everybody who wants to do complex software development. It is, and remember that this book was written in 1975, then revised in 82, and 20 years later in 1995. Most of the things still hold true to this day. This is how seminal this book is. In an industry that looks as if it's changing every day, and that we have new and shiny technologies that we can use and so on. Somebody wrote a book in 1975 that is still valid 45 years later. Amazing. And he talks about a few things. And he's also known for a second thing, which is no silver bullet. I'm also going to talk a bit about that. But first of all, let's go through the Mythical Man Month. A few ideas that come from this. The first one is Brooks' Law. Adding manpower to a late software project only makes it later. How many times have you worked in a project where that was going behind schedule and you heard managers saying, oh, we'll just add more people, right? Because if you think in terms of managing any other domain, if you're building a bridge and you notice that you are behind the schedule, you can just add new people and most likely things will work, right? You will get back to schedule. Problem is, programming is different. And this is what Brooks noticed. So he made this error of adding more people to this complex project. But he realized that he learned that it doesn't work. And then he went back and thought, okay, so why doesn't this work? And basically what he says is measuring useful work in man-months is a myth. Complex programming projects cannot be perfectly partitioned into discrete tasks that can be worked on without communication between the workers and without establishing a set of complex interrelationships between tasks and the workers performing them. Therefore, assigning more programmers to a project running behind schedule will make it even later. That is because the time required for the new programmers to learn about the project and the increased communication overhead will consume an ever-increasing quantity of the calendar time available. When n people have to communicate amongst themselves, as n increases, their output decreases. And when it becomes negative, the project is delayed further with every person added. So, and the group intercommunication formula, n times n minus 2, 1 over 2, it's actually because everyone is communicating with n minus 1 people, and then you only take half of them because you cover the others. So you have n people, and people are communicating with n minus 1, but then you take half of them because it's two-way communication. So if you have 50 developers, this gives you 1225 channels of communication. And this shows why small teams work so much better in software development. If you have 5 people, guess what? 5 times 4 over 2 is 10. 10 channels of communication. So this is one of the reasons why small teams, as discussed in XP, in Scrum, in other flavors of Agile, actually work that well. This also shows another thing which I've been talking about for a while, which is it's about knowledge. Programming is about managing knowledge. It's about refining knowledge. You take knowledge that is unrefined. It's needs and wants from product managers, product owners, customers, users, whatever. And then you refine them all the way to code, and code is a way of encoding knowledge. It's a very precise way of encoding knowledge because it is compiled, it is checked by a computer, and computers require knowledge that is very, very precise. And so the thing that you are actually doing as a software development team is you refine knowledge. You take knowledge that is very imprecise, very unspecified, and then refine it to the point where it's very precise. And in order to do so, this is one reason why you cannot partition this into discrete tasks, because knowledge tends to cluster. It's a network. It's a graph. it's not something that you can split in discrete things. And okay, we've learned in the meantime a few techniques for managing this. Like in domain-driven design, we use domain modeling to extract bounded contexts and things like that. But this observation still holds, right? So this is fundamental thing. Another thing that he says at some point in the book is that it's about prototyping. Throw away one of the prototypes because you will rewrite it anyway. And this is so, still today, people don't accept this, but this is exactly what we are doing. If you start from a prototype and you kind of add features to it and so on, you will inevitably end up rewriting it. Now we have learned in the meantime through refactoring to rewrite it incrementally. So instead of rewriting it from the very beginning, we are rewriting it, well, I mean, throwing it away and then writing another one, as he was saying. We are now rewriting it incrementally. Yeah, but that is still, again, it's a valid observation, it's something that holds. I would argue that in many cases we're actually doing 3 times. We are doing 3 iterations. And only on the 3rd iteration we actually learn and obtain the actual design. Another thing that he was talking about, second system effect. When an architect designs a second system, it is the most dangerous system they will ever design because they will tend to incorporate all the additions they originally did not add to the first system due to inherent time constraints. So they are susceptible to over-engineering it. It's always a tendency, right? We make a product and then we think, oh, if only we had more time. And then we go to the next one and we start over-engineering. And this is how I've seen a lot of my colleagues back when I was working outsourcing. A lot of my colleagues were starting with a framework, which was basically completely over-engineering, starting by designing a framework that would fit the project. And this is completely the other way around. And once again, we have learned to avoid or to reduce this over-engineering by techniques such as test-driven development, which allows us to just focus on one feature at a time, and other incremental development techniques like user stories and so on. But it's still valid. It's still a valid observation. Another observation, in a suitably complex system, there is a certain irreducible number of errors. Any attempt to fix observed errors tends to result in the introduction of other errors. And it's referring Heisenberg's, which is it's quite funny. This is expected. To me, in a way, this is somehow, in my mind, this links to Gödel's incompleteness theorem. I think these things are related. But I'm not sure we have any proof yet. Another thing that he was talking about, how does a large software project get to be 1 year late? Answer, 1 day at a time. And so what have we learned in the meantime? Don't treat a large project as a large project. Treat a large project as a set of smaller iterations. If you can deliver every 2 weeks what you promised, then you start seeing a trend, right? Or every week or every day, right? But when you are trying to track progress for something that is big, it's much harder. And it's actually what he's saying is basically impossible. Conceptual integrity. To make a user-friendly system, the system must have conceptual integrity, which can only be achieved by separating architecture from implementation. A single chief architect or a small number of architects acting on the user's behalf decides what goes in the system and what stays out. The architect or team of architects should develop an idea of what the system should do and make sure that this vision is understood by the rest of the team. A novel idea by someone may not be included if it does not fit seamlessly with the overall system design. In fact, to ensure a user-friendly system, a system may deliberately provide fewer features than it is capable of. The point being, if a system is too complicated to use, many features will go unused because no one has time to learn them. We still haven't learned this lesson. Except, well, a few tools. Basecamp does this really well. It provides fewer features than it is capable of. And because of this, it's very easy to learn. It's very easy to adapt to whatever you need to use. So this is such a powerful idea, and we are still not there. We are still adding features that should not be there. We are still not thinking about the product as something that needs to be as small, as supple as possible. Well, there are tendencies, right? And there are companies who manage to do that. So let's not generalize, but many of the products that I see are actually not like this. And this is very, very interesting because he was talking about this in 75. In 1975, I don't think that the concept of usability was very used. And I'm not sure even if it existed back then. It was introduced, as far as I know, by Donald Norman, but I don't know exactly the year. And so he was already thinking in terms of user-friendly systems. Incredible, right? And talking about basically having a designer that makes decision. He called the designer architect. Could be an architect, could be a designer that makes decisions in a way that, things fit well to one another and not just to add more features. And we know that feature creep is still a problem today. All right, so he also talks about other things, lowering software development costs, to buy things off the shelf when possible. Took us a while, not invented here syndrome, still happening today. We should buy more things off the shelf, I think. This is another one that I find, I didn't actually remember this one until I reread the summary. It's been a while since I've read the book, but I think I will reread it soon. Specialized tools. Instead of every programmer having their own special set of tools, each team should have a designated tool maker who may create tools that are highly customized for the job that the team is doing. In addition, system-wide tools should be built by a common tools team overseen by the project manager. I agree with this. I mean, we are still doing, software development is very varied in terms of activity. You can write code that just links two services together, takes data from one service, moves it to other services. Or you can write, AI code, or you can write user interfaces and so on. Having a single tool, even if it's an IDE, having a single tool for all of these, and IDEs today have a lot of features, but having a single tool that helps you with everything that you want to do in software development, it's just not possible. You should have specialized tools. And some of this happens now with DevOps, but some of it doesn't. We are still not doing this, right? Okay, so let's talk about the other thing, which I believe is very, very interesting, and that is the paper that he wrote. It's a seminal paper, is still valid. No silver bullet, essence and accident in software engineering. And the premise is there is no single development in either technology or management technique which by itself promises even one order of magnitude improvement within a decade in productivity, in reliability, and simplicity. So what he's basically saying is that we cannot improve 10 times, or he was saying in, I think it was, this one is published in 1986, but it holds for like 20 years or more. And his argument was that we cannot have a 10x improvement in software development, productivity, reliability, or simplicity just from a single technology or management technique. And the thing that's most interesting about this tool, about this article, is the reasoning behind it. So he's talking about two types of complexity. He talks about the fact that for every software development endeavor, you have essential difficulty and you have essential and accidental complexity, right? You have essential complexity, which is mostly related to the problem domain. The problem that you're trying to solve is as complex as it will ever be, all right? You cannot reduce the complexity in the problem because that is what it is, right? No matter what technology you are using, you still are left with this essential complexity. And the other part of it is the accidental complexity, which is mostly about the solution, about the technologies that we use, about technical debt. It's one form of accidental complexity. And because of this observation, he notices that, okay, even if we manage to reduce complexity, accidental complexity, this still doesn't reduce the essential complexity. And that's why you cannot expect to have a 10x improvement from just one technique. And the article is much more than this. But one of the things that we realize is, okay, we actually cut down on complexity. So today we know we are using certain styles of APIs like REST APIs, things like that. This is one way in which we've cut complexity. We don't have so many choices, right, when designing APIs. object-oriented programming, and so on, things that help us managing complexity. But one thing where it's really, really important to understand this is if you're doing any kind of, let's say, Scrum, and you use user stories and you use planning poker types of estimates. What we were saying about planning poker is that you should estimate complexity of the problem. And that is correct as long as the complexity of the solution is linear or is very low, right? It doesn't impact as much. Because if your estimate is basically, most of the work is in figuring out the problem and implementing it in the simplest way possible, and we have some friction with the existing system, which is the accidental complexity, but very little friction, then you're good. Your estimates will be good. But what happens if the friction with your system is much higher than the complexity of the problem? Well, then if you just estimate your complexity of the problem, you will end up being much slower than expected. And this friction is actually technical debt or problems with design. If your design is not flexible enough to accommodate new features, then what you have is a system that is actually pushing against you. Whenever you try to add features to solve new problems, it's actively pushing against you. And you need to fight and struggle to get this fit into the system, to get a new feature. And so when this happens is, you have a lot of problem. The only way to deal with this is to reduce your technical debt. And this is how you fix your estimates. And this is why usually when people come to me and complain and ask, okay, how do we do better estimates in Scrum? Fix your technical debt. Because otherwise, you don't know how much push it will be. So even if you have a very clear estimate of the complexity of the problem, you have no idea how much the system will push against you. Sometimes it will be very little, sometimes it will be a lot. And so your estimates will be highly variable compared to the actual results. Yeah, you'll have a very large variation in error. And it's interesting that he was talking also about program verification, and that, there is no magic here either. Mathematical proofs can also be faulty. Verification might reduce the program testing load. It cannot eliminate it. It's something that we know. More seriously, even perfect program verification can only establish that the program meets its specification. Right? So whenever you have a automated testing strategy, this will actually check things. It will not test them. So checks will basically check things against a specification. You still need testers to test that it does what we expect it to do in human terms. All right. So I won't go into more details. I think this is what I really wanted to talk about, and just to raise awareness in case you didn't know about Fred Brooks. look, he was an amazing person, and he had a lot of contributions, seminal contributions to this field. Everybody should read The Mythical Man Month. Everybody should read his No Silver Bullet paper, actually. Grady Butch also links here to an interview with Fred Brooks, and that interview is very, very interesting as well. So this is just me encouraging you to learn more about somebody who has had amazing contributions to the field. And just to push against this idea that software development is only about the new things. It's only about, the last framework, the last programming language, It's not. Most of the things that are fundamental to software development have not changed. We have just learned and found ways to deal with those, right? And so I leave you with one funny interpretation of Brooks' law, which says that you cannot, if you want one child in 1 month, you cannot leave 9 women pregnant, because you'll not have one child in 1 month. You'll have 9 children in 9 months, right? I've always found this funny. So, maybe you can apply this to your own work, but highly encourage you to read the work of Fred Brooks and read more about him, because he was just very, very smart person. That's it for me today. Thank you so much for watching. Thank you kindly for the view. And until next time, remember to think, design, and work smart.